This conference will now be recorded.
So before I start the session, any queries? If you have some open questions, you can ask.
Yeah, hi
Reddy, can
Vishnu.
you? Yeah, hi
Yeah,
Reddy.
hi Vishnu. Yeah, I am from like performance testing background actually.
Yeah,
So yeah, as part of performance testing, I know what are the metrics we need to capture, and apart
yeah,
from that, performance engineering I heard and QoS engineering. Just I
yeah.
want to know the difference between these three, and
Mhm.
in going, I mean, in future going forward, what is the benefit of engineering and QoS engineering?
Yeah, yeah. So that's a very good question, Reddy, and you brought out the point also very well. So see, you are into performance testing background, and obviously, performance testing falls into a group called NFT, right? Non-functional testing. So chaos
Yes,
engineering is
correct.
also one sort of NFT, right? So basically, what happens in
Yes.
nowadays in the organization is there are two ways organization work. One is they have a chaos engineer who is a full-time role, right? Like who totally concentrates on the chaos engineering activities. The second type of role is basically like, let's say you are into an NFT, so you will parallelly do the chaos engineering activity also. Like I meant, like you will be handling two domains, maybe performance and chaos, or some other testing. But generally, what I have observed is performance engineering and chaos engineering, they will go hand in hand, because it's very there are a lot of similarities, right? Because the environment what
Yes.
we use, and it's also infrastructure oriented, and performance is also infrastructure oriented. So there are a lot of common things between these. So that's why yeah, as a performance tester or an engineer, chaos engineering is always a what I can say, an extra uh, knowledge which you can have and also grow in your domain.
Okay, but I know the difference between performance
Hmm.
testing and performance engineering. So
Yeah,
performance testing, what usually what we'll do, simply we'll get the critical scenarios and we'll execute the script, and we'll prepare reports for server metrics and client side metrics like response times, throughput, hits per second. And if we observe any auto scaling, any CPU memory and net latency issues, just will inform development team, so they will look into deep drive, so backend what is happening and all. If that is performance testing will do. But
yeah.
if it is
Hmm.
performance engineering, like if you find out any bottlenecks, then we need to deep dive into the backend servers, we need to resolve the issue. But
Correct.
QoS engineering, what will do exactly, Vishnu?
Yeah, right. So see, especially this we will see in very much detail when we go with the course. But just considering this way, like in performance testing or engineering, let's say, we are mainly focused into the load and stability, right? Like how the system is behaving under load,
Correct.
under stability, and then we are trying to, even performance engineering is the next step, where we are trying to fine tune the bottleneck, right? So that's performance engineering. But chaos engineering is mainly focused, and the main objectives behind doing chaos engineering is, first of all, we call it the resiliency, or to make it more simpler, that how well your system is recovering from any failure, right? So that testing is what we are doing, because nowadays, if you see, most of the testing domains are what we can say, it's like cloud, right? In cloud we have this problem, and also there are distributed systems which are complex. So what happens is the downtime matters a lot, right? So in chaos engineering, what happens is you worry about that downtime, or like how well your system is recovering from a failure. Okay, but we will try to
We
compare
can say that
different.
is a failover test, right? We
Yeah, that's a
can
very good
say.
question. That's what I was coming into. So you will clearly understand how the failover testing and other testing is different from chaos when we start the sessions. Yeah, you'll come to know. Okay.
Okay, okay. Yeah,
Yeah,
sure. Thank you.
it's truly very different, because the objectives of both are very different. Okay.
Okay, yeah.
Yeah. Any other questions, anyone? Hi, Vadivu.
Vishnu Narasimha here. One question.
Yeah, Narsini, yeah.
Yeah, for the chaos engineering, do we need any kind of coding background or anything for that?
No, it's also again like a performance testing domain only, right? So everything is tool based, and coding as such you don't need. But again, you need to have the architecture knowledge, the infrastructure knowledge, like we do in performance, right? Similar to that.
Okay.
Yes.
Yeah,
So
hi,
So,
this
nowadays
is
it's
Shantanu.
becoming very common. Like, see, in all your organizations, you would have heard this innovation. Like, we need to innovate, we need to innovate. But it becomes very difficult for people to come up with some innovation. But this chaos engineering as a domain now, as a POC, or like what happens is nowadays it is growing a lot, okay, because many organizations are implementing it. So as an innovation point of view also, and implementing it, this chaos engineering helps a lot, okay, to grab that visibility. The second thing is obviously what I expect, maybe by now you even not, if not now, at least maybe in the next few months, your client or your project itself will adopt chaos engineering. That time you might you, it will be very useful for you if you have a heads up in that, right? So that way, to be, it might be useful for you, okay, in the going ahead, if you are a performance engineer or a chaos engineer, like if you are into performance, even other testings also. But if you are into testing domain already, it will be easy for you to learn.
Vishnu, this is Shantanu here. So currently, actually, I'm working in like ETL kind of testing, okay, using the Informatica and all.
Yeah. Mhm.
But like in upcoming days, like I have to work in AWS Event Bridge. So in that case, this case engineering, how like it will be helpful for my that uh, AWS Event Bridge like testing kind of thing.
Yeah, so Shantanu, so in this chaos engineering, if you see, in this course also we are covering a bit on AWS, right? And also some concepts like Kubernetes and Dockers and containers, even in depth into like how we do chaos engineering on these systems. Because as I said, chaos engineering is more like it grew a lot due to the cloud, right? Once cloud grew, or how the cloud adoption increased, chaos engineering is also increasing, because wherever there is cloud, or wherever like any organization who are who implementing cloud, they have problems, like they are implementing very high level technologies like auto scaling, or even the different DBs and different technologies, different like Kafka and all those, right? But at the same time, the complexity of the system is also increasing a lot. I'm audible, right?
Yes, yes.
Yeah. So the complexity is also increased. So this complexity which these systems are adding led to one more domain which everyone required for the testing, because that integration and how these complexities are working together led to a lot of problem, right? Because that we will understand how it is. So chaos engineering is such a domain which is for such new generation technologies, or infrastructures, right? So yes, so obviously the cloud, we like what I will say is, yeah, if you are into cloud, chaos engineering will surely come into your path.
so Vishnu,
Uh,
like security vulnerabilities, like attacks, everything, this comes
Mhm.
under chaos engineering.
No, no, that will not come. That will come into security testing only. Here, mainly, we will be doing all the test cases, scenarios, and all, with main objective or outcome mostly on the recovery of a system, right? How well your system is recovering, whether it's fast or slow, and that too, how you inject. See, now the it's more sort of, your system can fail due to multiple reasons, right? It can be any, like it can be network, it can be resources, it can be some maybe some malware attack. But that failure, how it happens, so we will have to simulate it, right? So for that we have the tool, the injection, right? Once the simulation happens, then you need to understand how your system is behaving, how fast it's recovering, what are the values you need to collect, report metrics, right? And how you match it with the SLAs, what are the SLAs we do, like what are the metrics we are interested in chaos engineering. So all those things will come, right? So yes, so but it's not related to security, okay? It's totally into recovery
so it's
and use.
basically
Yeah.
So basically, it's kind of performance testing. Like how can we improve the performance of the application or like
Not
that kind
performance
of thing.
exactly, because see, in performance, you increase the load for a failure, right? But do you
Yes.
add something like, okay, I increase the network latency. Okay, I increase the
Oh,
network
okay.
latency and see how the system is failing. Or let's say I inject a failure, like I do a black hole attack, where black hole attack is like there is a sudden failure of a service. Okay, due to that
Hmm.
failure, how my other services will fail. So something like, but I am not using the word fail, okay, because then again, as Reddy asked, like what's the difference between failover and chaos? That question will come. So that's why the fail word generally in chaos engineering we will not use. It's more about recovery, okay? So that we'll understand once we go through chaos engineering in detail.
Okay.
Yeah. Okay, so I guess let's start, okay, with the sessions. And like today, it will be more sort of an overview, like what all we are going to cover and how the course will be and all those stuff. So let me share my screen.
Vishnu, one last question. Like
Yeah,
the
yeah,
timings,
possible.
it will be
Right.
the same every day. This time
Yes, yes,
or
yeah. It will be
okay,
the same time.
okay.
Because this is what we like when we did a poll, like most of them agreed on. Let's Yeah, because morning time we tried, but it didn't work out somehow. So team decided to shift it to evening, my time, IST. Yeah, 9 p.m. IST.
Is it possible to move like 1 hour before or 1 hour after?
Uh, Currently we are sticking to this time, but
Okay.
once the final batch comes out, right? But most probably this will be the time. But
Okay.
once the final batch comes out, and if everyone agrees on some small shift, maybe we can decide on that. But again, it's based on the major audience. Okay, the final batch.
Okay.
Yeah. Okay. So let me share my screen. So basically, in our course, if you see chaos engineering, so we can divide any practice into four important stages. Okay. So one is the planning stage. The second
Are you
is
sharing
the
any screen? Let me
no, I'm
see.
just opening a tab. Yeah, I will share soon.
Okay.
So we have planning, then we have the execution. I mean, like scripting or that test setup stage. Then we have the execution, and then we have the result or reporting that stage. Okay. So similar way, what I have done is I have divided this course in such a way that we go in that procedure only. Okay. So that you get an end-to-end understanding of what is happening. So let me share. I'm now sharing my screen. Let me know if it's visible. Visible now?
No.
Not yet?
Yep, we can see now, Vishnu.
Yeah. Okay. So let me give you an overview so that way you understand how we progress, what are the tools we will learn in that process and all the stuff you learned. Okay. So yeah, let's divide it to planning. Then I will call it test setup, then execution and reporting I will give. Okay. So these are the main four stages. Okay. When we speak about any testing practice or even any task, okay, mainly focused on testing. So in planning stage we will learn how what basically we'll try to understand like what is chaos engineering, how do we plan our chaos engineering activities, how do we create the test plan, how do we consider different like how to read an architecture, and from that how to come up with the test cases, use cases, and all those stuff will come in the planning stage. Okay. In the test setup we will learn how to implement our tools into the infrastructure what we are using. So see, what happens is now this chaos engineering is a new domain. Okay, so it's not a like very primitive or very old, right? So generally what happens is who are working in chaos engineering, they will have to sometimes install that tool also onto that infra, right? So we need to know how we install the tool, how you set up the tool, like how you link it with your infrastructure and all those. So that we will learn in our test setup. So in test setup stage, we will learn basically two tools. Okay, one is Gremlin and the other one is Chaos Mesh. These are the two tools which we will be using for our chaos engineering activity. Gremlin is a very common, or it's a paid tool, okay, for chaos engineering, and many organizations are implementing it. Chaos Mesh is an open source tool. So one open source tool, one paid tool. So that if let's say you are implementing in your organization and if they don't want to go with the paid one, you can go with the open source one. So in that way, it will be useful for you. So we are covering two tools. One is Chaos Mesh and the other one is the Gremlin. And obviously, there are a lot of other tools also in the market, but these, if you know, others will also become very simple for you because it will cover most of the things. Okay. So in the test setup, and also in this process, you will learn Kubernetes, Docker, containers, and how they function, what are their significance, how do we even the cloud functions like auto scaling and different other concepts. Okay, we will see like not like just seeing, but like a hands-on, right? We will have our own Kubernetes cluster onto which we will deploy our own application, and on that we will do the chaos engineering activity, right? So this way you will have your own setup of everything, right? It's not that you will be just learning the theory, you will be doing the hands-on. Okay, then we will move on to the execution stage. We will see what are the different types of failures, injections, like what is black hole attack, DDoS attack, and different attacks. How do you do that, right? So that you will see in the execution, how you set up a scenario, what are the things you need to take care when you're running a test, different execution strategies and all you will learn when we go to the execution stage. In the reporting stage, what are the metrics you collect, and what all you need to monitor, how you monitor, and all those detail, all those things, and how you create a report, right? How you report and all those stuff we will be seeing in the reporting stage. So our progress will be from planning to reporting. Now obviously, with only this, in the reporting stage, we will learn about Grafana. We will use Grafana and Prometheus so that we can monitor our test and all. And even we will learn how to set up Grafana Prometheus also quickly. Okay. So, basically, you will be doing it in your own machines. Okay. So you will get an understanding how you do it. And once this is done, we will be moving on to the CI/CD part, because this is very common nowadays. Everyone wants to do automation in their projects. So you need to know in a high level way how we can automate chaos engineering, right? So that we will use Jenkins. In that process, we will learn Jenkins also. So this is how our course will progress, right? So any questions, anyone, till now? Any doubts or any queries?
One
Okay.
question. So
Mm. Yeah.
Gremlin and Chaos Mesh, you told both the tools, right?
Yeah.
So both the tools
Right.
can do the same thing, or like
No,
functionality wise?
both does same thing, but there are some limitations when it comes to Chaos Mesh because it's an open source tool, right? Gremlin is more sort of like a software as a service, right? SaaS, where you have their own the setup and other things are little easy because it's a paid one, right? Chaos Mesh is little not that easy as Gremlin, and also if you see there are some things like scheduling the attack, or like for example, which are not there in which we will see, okay, when
Okay.
we work on it. But pretty much it will cover, like it's more sort of Jmeter and LoadRunner, right?
Okay.
Yeah,
Okay.
something like that. Any other questions, anyone? Yeah, so this is the course just to show you the course syllabus. First, we will be starting with the introduction, as I said, planning stage. Then we'll be seeing some experiments in Chaos Mesh. Then we'll be seeing how to capture the metrics using Prometheus, Grafana, and how to create the reports and all. So first is obviously introduction, where we will see and we will understand what are the principles and process of chaos engineering. Uh, then different, like how to create a test plan. You and we'll, as I said, we are covering two tools, right? Gremlin and Chaos Mesh. So in whatever we do in Gremlin, we'll be doing on Chaos Mesh also. So both ways you will learn, like how you perform the experiments on both, right? Like how you perform the network experiments or state experiments, how you do that in both the cases, both the tools. Okay. And you obviously you learn Kubernetes containers. So see, nowadays, because I don't need to call it out. It's like a need, right? Kubernetes and these things you need to know, okay? Because if you don't know it, then I don't know, like you are in trouble. Because nowadays every organization is implementing these cloud, even distributed systems are very becoming very common. Mainframes are disappearing, right? The mainframe systems are moving on to low code, no code, right? And so it's becoming very complex nowadays. And if you are not aware about these concepts like cloud, Kubernetes, Dockers, containers, and these even like what are these platforms, how do they, at least in a high level way, it it will be difficult for you to sustain, right? So even like so this is a need of this period. So we need to cover those things, right? And chaos engineering, as I said, it's a new generation technology testing, right? So obviously it will have we will have to cover these things. So that will be covered in this course. Okay. So, any questions, Narsima or anyone? Any doubts till now?
One last question, like how many hours is this training is going to be?
Yeah, it will be around 20 hours, 20 working days. But based on how the audience interactions, it might go to 20, 25 and all. But generally, if your interactions are not that much, it will be finished in 20 working days. Narsima, daily 1 hour.
Okay, okay.
Yeah, yeah.
It's going to be hands-on, right? One thing just.
Yes, yes, right, yes. So everything will be hands-on. Most of like 90 percentage it will be hands-on. Theory part will be only that initial part where we understand, because see, chaos engineering is a very new domain, so people have a lot of questions what it is, right? So that we will cover, because we need to understand what it is, what's the objective, what's the outcome, right, of doing all this. Otherwise, there's no use of doing it, right? Like if you don't know what are we looking into, or what is the outcome which my customer or the client will get out of it, right? What's the ROI? So yeah, that part we will be having a bit of a theory, like maybe 10% of the total course, and 90% will be hands-on.
Okay.
Yeah. Okay. So let me. So I will be sharing the materials also to you all related to the course, which you will be like, which you can use. I mean, just to go through whatever I will be teaching, like whatever I will be taking here, you'll find all those documents in that drive. Okay. So this is the folder which I will be sharing with you all, with all the materials, even like different lecture modules, different, like see in some situations we'll be using some softwares, right? All those files, codes, everything you will get it in this folder itself, which I will be using in my course. So this I will be sharing with you all once we start the course. Okay, I mean like once we finish the demo sessions. And also I'll be giving you a Gremlin enterprise license. So generally there are two ways you can utilize Gremlin. One is a free trial, which you get it. Like I guess it's for 2 weeks or something, because I didn't use the free trial from little long, so I don't know how the policies are now. But yeah, generally the free trial is for 2 weeks, and you will get some limited number of attacks also based on the free trial. But in our case, what we will do is, I will give you this enterprise license access which I have, okay, of Gremlin, and that I will keep it available for you all, maybe 30-45 days as per your need, okay. And once, like, I generally don't remove the person from here, because not required as such. But if in case the team grows a lot, okay, because of multiple batches which I take, I might remove the older ones after 45 days, anyways, not like in that 1 week or 2 weeks. So you can, like, you can make use of that enterprise license of Gremlin, which will have full, like, all the options and like, what all you can explore fully the Gremlin. Okay, with free trial you cannot do that, right? So that also I'll be providing you once we finish move on with the real sessions. Okay. Nansima, any questions?
Oh,
Reddy,
no, I'm
Sri,
good.
Shantanu?
Yeah, that's fine. I'm also good actually.
Yeah. So no need to worry about the coding knowledge, because as I said, it's I even I can say it like a zero code, or not zero code, maybe 2%. Because what happens now, you might learn one section where you understand how to read a YAML file, how to write a small YAML document, okay, which is very easy. Like, it's like a basic English language only, okay. How to write a YAML, and that will be very useful for you also when you are maybe performing with performance testing also. Because nowadays you'd have heard, like, there are some questions in the which generally comes, like, how you let's say, how you implement Jmeter into a container or into a Docker, or how do you run Jmeter in a Kubernetes cluster, right? So that in those situations and all, even if, like, how we write a YAML will be useful for you all, okay, because you learn how to because YAML is what you use for those purposes and all. Okay, so except that, coding is not at all there, right? So you don't need to worry about it. Everything is through the tool, right? The tool is very extensively used. Okay, yeah. So okay, so let's start with the module 1. Okay, so can anyone just give me a like, let it be wrong or right, but what is your understanding of chaos engineering? Like, what you thought about chaos engineering till now? Anyone? Let it be wrong, okay?
Uh,
We are all
yeah,
here
yeah.
for
As
to learn.
per
Yeah.
my knowledge, chaos engineering is like we need to forcefully do some pressure for servers, and
Hmm.
then we need to check how quick it is.
Okay. That quick word I will remove. Okay.
Mhm.
So we'll come to that.
Okay.
Any
Yeah,
other
yeah.
any other answers?
Like attacking with some kind of, you can say like a malware or something and trying to recover that one.
I will remove that word malware. Okay. So
Okay.
let's remove that. But that attack word is, yeah. Okay. Any other answers? Okay. So see, take a scenario. Like, let's say, uh, this is my server. Okay. Whatever I have. Okay. On which my application is running. So consider server. I will explain you what server and all is, even like someone have still that doubt, right? Like, what are servers and all. Uh, Generally, a high level way people know it, but little in depth, still we have confusion. But for now, just assume server is the house in which your application is running. Okay, so if the house is not there, obviously that application is not there. Just assume that way. Okay, inside the house, my application is running. Now, let's assume there is a storm. Okay, there's a storm coming. Okay, now this storm can hit either the wall, right? It can hit either the wall or either the roof or maybe the door, right? Or even maybe some other pipe which is there here, some pipeline. Okay, it can hit. It can hit anything, right? But do you think if it hits the pipe or if it hits the roof, both will the problem be same which which that house will face?
No, problem is different.
Problem will be different, right? If
Different.
the
Yeah.
pipe is hit, water connection is gone. If the roof is hit, like everything, whatever is like even the rain or something comes, it will fall into the house, right? So based on the, but if you see what is happening here, the thing is same. It's storm, right? Storm is what is hitting the house, but it's where it is getting affected. Based on that, the implication or what is happening is changing. So based on the attack, what we are doing. So here the storm is, you can consider as the attack. Okay, what we are doing, and on this is the attack what I am doing, and on what I am doing, right? Attack what I'm doing and on what I'm doing in the server, like whether it is the specific service or whether it is the DB or whether it is the front end server, whether it is a load balancer to which I am attacking, right? Based on that, my outcome will change. Like how my house will behave or how my application will behave will change. Will it change or not?
Yeah, it will change.
It will change, right? So that's what we study mainly. So what we are studying, that's what we study in chaos engineering mainly. But now to narrow it down further, what exactly do we study, right? So what we study here is, now this house, there's a storm coming, the house fully fell down. Okay, let's say now to build this house again, let's say I take 1 year. Okay, that is one scenario. Now let's say a storm came. Okay, and this door, right, like it hit the door. Okay, door went off, and to refit the door it took me 1 month. Okay, now in both these cases, in which house the damage is less? Which house the damage is less? First one or second one?
Second one, door damaged.
Yeah,
Second one,
second one, the damage is less, right? Similarly, so the person who is staying inside the house B, he will be able to uh, like stay in that house faster compared to A, because here it will take 1 year for the house to be reconstructed. So till that, that person has to stay somewhere else. Like, but here he can come back and stay in just a month, right? Now the person want, what I'm saying here is our application, and the house what I'm saying here is the, let's say, the server. Okay, so now if A and B are two servers, which do you think is a good server? The application
B
will
is
start running
B
in
is the good
will
server.
start, yeah. So the application will start running again in 1 month. The application will start running again in 1 year, which is a good server.
1 month is good.
Yes, right. So that's where the recovery comes into picture. So here in chaos engineering worry about how fast your system recovers from any failure. Now, see, when a failure happens, a door, I need to fit the door back, which is manual. But what if some failure happens and my system itself comes out of it? Or like let's say there are two houses. Okay, I have two houses. One door went off. What I will do? I will go and stay in the other house. This door will get fixed. Then again I will come back to this house. In this case, is this problem affecting my stay in the house in any way?
No.
If no, right? So same thing with the applications also. So if I have two servers, if one server fails, automatically my another server tool should take over and serve my customers that application. But this takeover, right? This is very important, okay, in chaos engineering. Now, if it is a failover testing, right? In failover testing, what will happen is now you have one server, server one, server two. You have server one, server two. In failover, what happens is when your server one fails, without any delay, server two should take over. I mean, like that failure should not be visible at all. So that is failover, right? But in chaos engineering, it is not like that. That let's say from server one to server two, it takes around 5 minutes, like to for that application to use server two, it will take around 5 minutes. Okay, it will take 5 minutes to come to server two and then start serving the customer. So this 5 minutes time is the recovery time after failure. Okay, so and this one is what we are interested in chaos engineering. We don't say that system will not fail. No, it will fail. Okay, but once it fails, it will recover fast. Clear, everyone? Any doubts? How it's different from failover and how the chaos engineering is different from failover? Any doubts?
Can you elaborate more
Hmm.
differences? Vishnu?
Yeah, because
Looks
this is
like
what
both
the
are
yeah.
same only.
Mhm. Okay. Okay. Let's say actually, if you see the definition of this failover, right? Basically, there you will see this word withstanding failure. Okay. But in chaos engineering, we don't use withstanding failure. Failure will occur, but we talk about resiliency here. Okay, so resiliency is not about whether your problem will come and your system will be able to stand the storm. It will fall, but it will quickly stand up again. Okay, rather than a continuous failure. Continuous means like, okay, it fell down, but it will not stand up at all. It will be in a failure state only. Clear, all of you? Any doubts? Okay, so right. So now let's say we are speaking about the rise of chaos, right? Like why, what led to rise? We spoke it already, but just to give a quick overview again. Anyone can you anyone like any of you explain me what are distributed systems? Anyone?
Distributed system
As I
means
said,
like
yeah.
split the load, right? User load.
Okay, yeah, so that's fine. Like because I totally understand you're from performance, right? So that user will be, I meant like, yeah, that's a good way of understanding it. Yeah, but let's say if I don't think in terms of user, okay, so what do you think are distributed systems? Let's say we keep aside that user term. Fundamentally, what are distributed systems? Anyone? Let it be wrong, okay? We are all here to discuss, grow, learn together, okay? So
Nothing but
just
sharing.
call up. Yes, so that's a good word, sharing. Anything else? Okay, I guess most of you are new to that, then I will give you an overview, okay? Let's say there are three functions, okay, in my application. Let's consider some, let's say e-commerce, okay? There is accounts. So in accounts, we have this login, logout. I have grouped it, okay? Logout, then my account and all, okay? In this accounts, so which is I will give A, okay? Then I have orders, I will give B. So in orders, we have this checkout, ordering, and all those, okay? Ordering and all. Then let's say I have payments where I have the payment related thing. Okay. Now let's say before 10 years, I'm just going little up back. Okay. Before 10 years, or not even 10 years, before the distributed systems came into picture. Okay. So that time, let's say a user wants to order. Okay. Generally, in an e-commerce store, without login, can you order? Anyone? Without login, can I order?
No, we can
No.
add into the
Generally,
cart.
we
No.
yeah. So generally, guest ordering is some websites allow, but most of them don't allow, right? We need login, like the name, username, password, and address, and all, right? So login is required. Now, before the distributed systems came, right? Let's say Narsimha is from accounts team, like he's the developer from accounts, okay? And let's say Reddy is a developer from orders, okay? Now, before distributed systems came, unless Narsimha doesn't finish his development, Reddy has to wait. Agree, everyone? Because without login, my order will not work. So order has to work. Like I meant, like order, login development has to be completed so that Reddy can start developing orders. Agreeing, everyone?
Yeah, correct.
Okay, before distributed system. But once the distributed systems came, what happened is my A, B, C. Okay, order payments. So accounts, orders, payments. This A, B, C. Now, what is that main issue? Like, why fundamentally why Reddy has to wait for Narsimha to complete? What is that fundamental problem here?
He's dependent on login.
Yes, exactly. So the dependency. So somehow I need to remove this dependency. So people thought a lot about it. Okay, oh, like this is wasting a lot of time, right? And even like resourcing is issue. Again, there's a lot of dependency with each other, and also the systems are becoming bigger and bigger. So this dependency again created a lot of friction in the development process. So people thought, how can we reduce this dependency? Okay, so to reduce this dependency, so they came with a solution. Okay, so whatever happens inside A, whatever happens inside B, and whatever happens inside C remains inside it. Okay, but now these A, B, and C, okay, the only link between them will be common. Okay, so what I meant by with it is, like, let's say A is from Tamil Nadu, okay, B is from Andhra Pradesh, and C is from, let's say, Maharashtra. Okay, so A speaks Tamil, B speaks Telugu, and Maharashtra speaks Marathi. Okay, let's say. Now, when these three people meet, in which language do you think they will speak? Anyone?
We'll choose one standard language.
Yes. So let's say English, right? So let's say they
Yeah.
speak in English. They speak in English. Okay. Now, my question to all of you is: let's say A is writing a book. Okay. B is writing a book. C is writing a book. Okay. Now, and there is one guy D. Okay. He's summarizing all these books. Okay, he's summarizing all these books. Like his work is to, okay, summarize this book written by A, written by B, and written by C. Okay, now this ABC will also speak in English with D, right? Because that's a common language. Agree, everyone?
Yeah. Yep.
Right. So now this D guy, let's say he's from Kerala. Okay, he's speaking Malayalam. But irrespective of that, everyone is speaking with each other in English, right? Clear? So this D is summarizing a book in Malayalam. Okay. Now this book is in Tamil. This book is in Telugu. This book is in Marathi. Will that affect D in any way? Whether the book is in Tamil, Telugu, or Marathi, will it affect? Because B will speak to D in English, right? And B will say whatever it has written in English to D. Whether he has written it in Telugu or not, right? When he speaks to D, he will speak in English. He will say, okay, this is what I written, and this is the thing. These are the summary. These are the topics I covered. Everything, whatever he has written, he will give it in English to D. Though the book he written was in his language. So, are you getting now here A, B, C, D? These four people. Is there any dependency in their work? Like, is A dependent on B or B dependent on C on the book they are writing in any way?
No.
No. Okay. Only thing is D might be dependent because they have to complete writing the book. Then only he can summarize. But ultimately, see, there is no connection. What is inside, but outside they are speaking in a common language. So whatever they want from each other, they will get in English, which is a standard common language. But whatever is happening inside, it's their choice. They can speak in any language, any dress, any food, whatever they want, they can do. But when they come together, when they are speaking to each other, they speak in one standard format, or they act in one standard format. And this is where this English language is called APIs. Let's say in our software or in our application development, okay, it's English, this language English, or the standardization what we have is the APIs, and these A, B, C, D, whatever we are seeing here, are called services or microservices. So microservices are services which are independent from each other, but they communicate with each other using APIs. Clear, all of you? Any doubt till now? What are microservices and what are APIs? There's a lot of silence. Okay, call out any word which you didn't, which you got confused, like APIs or microservices. I
Can
hope,
you elaborate on microservices?
yeah. So see, now
Yeah,
this one is clear. Now coming
microservices.
to the next thing. Okay, so how now we will understand it with the application example. So now we have A, which is our orders, accounts. Okay, B is orders, and C is payment, right? So in orders, okay, this orders team, which is the A team, they will make, let's say, they will write the code in C programming. They will use DynamoDB, and let's say they are on cloud. Okay, let's say AWS. Okay. Now B, let's say they are doing on Go programming and they are using MySQL DB, and they are on some, let's say, Azure cloud. Okay. And let's say here we are the payment, right? So payment totally, let's say it's third party, not at all our development. Okay. Now let's say, are you seeing the complexity now? Even the languages what they are using is also different, though the application is same for microservices. A is a microservice, B is a microservice, C is a microservice. Now why am I choosing different languages, different DB? I can use same, no? What's the reason, do you think? Like why do we go with different languages, different DBs? What is the need of that? Because anyways, this is the same application, right? Part of the same application. And first question is, can I do that?
Same,
Can I do that or
same
not?
application using by multiple geographic location peoples. So in
So
that
see, no,
case,
here we are not speaking about any uh, like nothing about the load or something. It's just a even one user also, right? So here A is nothing but ordering, checkout. B is I mean like login, log out. B is ordering, checkout. C is payment, right? So login and log out code I have written in C programming. Ordering checkout code I have written in Go programming. Payment code I have written in some other, like it's a third party.
totally. So why do I do that? I can use the same code for all, no? Why am I using different coding language? Like, what is the use of doing that? Anyone? So you're getting my point, right? So this is the same code only, right? What I've done. Uh, okay, when I say ordering, what is ordering? Anyone? Are you getting the scenario? All of you?
Yeah, we got the scenario, Vishnu.
Yeah. So see, now let's say A team. Let's say Narsimha is the lead of that team. He is very good at C programming. So he went with C programming. B team is very good at good with Go programming, and what they found out is for ordering MySQL DB is faster. So they implemented MySQL DB because why they could do that, that we need to understand. Because A and B are independent. Because whatever happens inside B doesn't matter because they communicate using same language, which is API. Clear, all of you? So whatever is inside A, whatever is inside B, the services, the microservices. See, when I say microservices, you don't need to consider it as some microservices are group of functions, right? Group of functions clubbed together, like order, checkout, are one group. Login, logout, my account function is one group. Payment, then adding card, deleting card is a one group. So these can be different services. Clear? What are microservices? Okay, so let me put in this way. Let's say, let me assume like performance wise. Okay, let's take a performance example. This ordering, okay, button, okay, there's ordering button and a user is clicking it, 100 users are clicking it, 100 users are clicking it. Okay, there are, let's say, 4 CPUs. One is for accounts, one is for orders, and one is for payments. When this happens, which CPU will usage will shoot? First one, second one, or third one? Which one? Which CPU usage will shoot? This is where the distributed systems come into picture. See, this order
Load
is lying
balancers.
this order is lying in the second CPU alone. So it is not at all affecting login or logout. Are you getting? So even the resources also I can split based on the function. Clear?
Correct. Yeah.
Right? So when this happens, only the CPU of order will get affected. The login and other things are lying on different CPU. I mean, I can put it in different servers. I can do that. So that is microservices. Clear? Any doubts?
Yes, Vishnu.
Right? Narsimha, Survi, Shantanu, what do you?
Yeah, good.
Yeah. Okay.
Yeah,
Hi, what do you? So how's everything going on?
yeah, good, good. Still,
Yeah,
I'm searching for it. Yeah,
yeah. Okay.
but I could work on the things you thought. So
Hmm.
that's something is good going.
Yeah. We will connect later. What do you? Yeah,
Yeah, yeah.
sure. Okay. Yes. So that's it. I don't want to take more because I don't want to overwhelm you all with a lot of details. So see, to put it in a nutshell, okay, microservices helped us to develop things faster. Okay, because if you see order, accounts, payments, everything can be developed parallelly, right? And all can be integrated together. So the development became faster. Even technology adoption became faster, right? Because let's say B guys went for Go programming, A guys stuck to C programming, which is old one. That's fine. But B could go with Go. Like they were not dependent on A. Oh, A is using C, so I should also use C. No, because with microservices they got independency, right? Whatever they want, they can do. I mean, like I will not use whatever they can, but at least they had that independency to choose. between different options, right? That was one. And again, even problems also, B's problem remained with B, A's problem remained with A. So if A failed, do you think B or C will fail? Any idea? What will happen if A failed? Will B and C fail?
No.
No, B and C will not fail. That's the I mean, like, that's what we like assume 99% of time. Okay, but sometimes yes, it can happen. But 99% of time, since they are microservices, they will not fail. Right now, but this was not the case when before 5 years before distributed systems, because if login fails, the code was in the same, like it was all connected with each other, right? So if login fails, all other things will also failed because the code was in the same group of files, right? Or like in the same server. But now that's a good thing happened again, because let's say login is not working. Okay, still my customer can browse the catalog. He can do that, right? Because login is not running, but at least my catalog, the user will be like, whichever user is browsing the catalog, he will be able to browse the catalog. Only person or only people who are logging in or who require login will get affected, but other customers or other users will not get affected. So that was also a good thing, right, about microservices which happened. But as per testing is concerned, do you think things became complex or simple as a tester, especially if you are if you're into performance or chaos engineering, such domains where we need to test across the system? Did it become simple or complex? Any guess? As a tester, as a developer, it became simple, right? Because they are working on each A, B, C. But as a tester, especially who are working across these services, did it become simple or complex?
Complex.
It became, yeah, it became complex, right? It is not easy because one is using Go, one is using C, one is using DynamoDB, one is using MySQL DB, one is using Apache server, one is using Nginx server. Totally different, right? So, and these things are communicating with each other. And when you are testing it, this integration creates problem. Okay, and you have to solve it because there are a lot of integration layers, bottlenecks. So that is where the domains like chaos engineering came into picture. Okay, because with only traditional testing practices like performance and other testing practices, we couldn't uncover a lot of issues. Okay, so we came up with chaos engineering which can uncover such issues, and that's what we are going to see in upcoming sessions. How what like how it did, what it did, and what are we doing, and how we do it, right? So those questions we will try to answer, right? Any questions, anyone, till now regarding distributed systems? And let me know if I confused you somewhere, maybe through some example, uh, because I wanted to explain you little in an easy way rather than using a lot of technical terms, right? So I thought I'll take some example and explain you. But let me know, you ready or someone like clear about what are microservices?
Yeah, I'm good
Ready?
from my
Yeah.
side. Yeah,
Yeah.
I'm good from my side.
Okay. Narsimha, Survi.
Yeah, I'm good from my side.
Okay. Survi, are you there?
Yes, sir. I'm
A-
also
Any
good.
question? Yeah. Okay.
Oh,
Shantanu.
no.
Yeah, Vishnu, I'm also good from my end.
Okay. Vadivu.
Yeah, I'm good, Vishnu.
Yeah. Can you actually? I was just thinking. Okay, that's fine. Anyways, we'll continue. It's almost 10, right? Yeah, we'll continue then in the next session. So tomorrow we will see some hands-on on Gremlin. So we'll see how to set, like, just to show you how generally the attacks are injected. Okay. Before we jump into the next sections, I thought I will show you one action. So how the chaos engineering in action looks like. Little, it will be a jump to maybe second or third session, which I am just bringing it ahead so that you see what happens in chaos engineering in real action, right? Not only just theory and all. So yeah, that we will see tomorrow, how we use Gremlin to run an attack, and also different types of attacks generally in a high level way. In depth, we will see in the upcoming sessions what are different attacks and all, how to choose an attack. Because see, attack is also not that easy. Like, okay, there's a black hole attack, you run it for all. No, you, based on the system what you have, you need to choose the attack, right? So that we will try to understand. That also we will have to see. So yeah, all those things will come in. It will be exciting. Let's continue tomorrow. Okay. Yeah. Thank you all and have a very good day and good night. I'll meet you all tomorrow. Thank you.
Yeah, thank you, Vishnu.
Thank you.
Yeah.
Thank you.